So if we jump down here, so plane. A plane in math class looks kind of like a wall or the floor, but it goes on for forever, kind of like a line goes for forever. So a plane is just going to be an infinite flat surface. So an infinite means never-ending flat surface. So kind of like a wall or floor, but it would have to be a wall or floor that goes on for forever. So probably better if you're thinking like a ginormous factory wall or maybe like an airplane runway that at least kind of goes for a long ways in one direction. Something like that. Good? Parallel lines are two lines that kind of go in the same direction, right? Never cross is the official definition. So I'm going to put in the parentheses here kind of the symbol. The symbol is two like vertical lines side by side. And parallel lines, though, are two lines in a plane that never cross. I wouldn't stress too much about that qualifier, the in a plane. Kind of why that's there, if you can kind of picture it. If you picture a line that's running like side to side on the floor here in the front of the room, then if you picture another line that's going up and down on the wall, do you agree those aren't parallel to each other? One's kind of horizontal side to side and one's vertical. But if one's on the wall and one's on the floor a few feet away from the wall, they're never going to cross, right? So that's why they're saying two lines on one big flat surface that never cross. If you wanted to, you could like do an example, and just so people don't think they have to be horizontal, I'm going to pick a couple oblique lines that are going up on an angle, and just try to draw two that are parallel. That's not perfect, but it's okay. You guys okay on that? Now transversal, I think that's the new part, isn't it? So a transversal is going to be a line that crosses two or more lines. So a line that crosses two or more lines. I was really kind of surprised that the book defined it this way because, maybe I should say, the transversal is going to be this line right here. So this line is the transversal. And I was surprised the book said it this way because it seems like whenever they have transversals, the two lines that it crosses, or sometimes there will be three in there, but the other two lines are always parallel, it seems. But they didn't say that in the definition. I wouldn't worry too much about the transversal, but what happens is when we have two parallel lines and one line that's intersecting them, we get a whole bunch of angles forming. Agreed? And if you look at that, angle 1 is bigger than 90 degrees. Some would say it is obtuse. Nice. So can anybody tell me another angle on there by number that looks like it's the same measure as 1? 4 would be 1. Sorry, I blew it. 8 would be another. And there's one more. Go for it. 5. So 1, 4, 5, and 8 all look like they're the same. And 2, 6, 3, and 7 all look like they're the same. And if lines are parallel with one straight line crossing it, that's going to be true. Now we go through and we give names to some of these like pairs of angles that are equal. And learn the names. It's going to keep coming back until you're done with geometry stuff. So a couple of years from now when you take geometry, it's going to come back again. But if you take and think them through, if you look at the names, you can make it where it's somewhat logical. So if I have interior angles, if you had to pick angles that were interior out of these 8, which angles would you probably pick? Just holler them out.
7.
Maybe it's not as much as I thought. One is 3. Another one is 4. 5 and 6. Seeing it that way, do you agree these 4 at least are kind of on the inside?
Yeah.
So interior are like between the parallel lines. So I'm going to write that down. So between, and I'm just going to do the parallel symbol, between parallel lines. So in this case, my example is 3, 4, 5, and 6. I didn't bother writing a little angle thing in front of each of them. I was kind of lazy that way. Exterior angles are going to be outside the parallel lines. So exterior angles are outside the parallel lines. And the numbers that would be exterior would be nice. So 7, 8, 1, and 2. So they're the ones that are on the outside of the parallel lines. So those and those. Good so far? Now we take and we kind of combine those together. Alternate angles are going to be ones that are on opposite sides of the transversal. So number 1 is going to be it's going to alternate with something that's on the other side of the line. Or number 6 is going to alternate with something on the other side of the transversal. So if we have the alternate, then I'm going to say opposite sides of transversal. So opposite side or sides of the transversal. And now we just take and combine two of those together. So we want to have alternate, so opposite sides of the transversal and interior with angle 3. So if I'm starting here at angle 3, what angle is going to be interior and alternate? 6. You guys agree 6 is one of my 4 interior angles, and it's on the opposite side of the transversal? And you'll notice they're the same number of degrees. The things with names are pretty much always exactly the same number of degrees. So angle 6. Good? Yeah. And alternate exterior angle with number 2. So now if I'm starting up here with number 2, what's alternate and exterior? 7. Perfect, because alternate means it needs to be on the other side. And the only one that's on the other side that has the same number of degrees is that number 7. So it'd be angle 7. You guys okay on those? My way of remembering corresponding angles is kind of dumb and it might not work for you. But I think of this. I think of a war correspondent, so I kind of stick with that correspond thing here. A war correspondent tries to tell you what it's like in Syria or what it's like in wherever they're fighting. They're fighting all over. North Korea and the South China Sea. So the correspondent tries to give a report that lets it be like you're in the same place. Fair enough? I'm going to say we take and cut this baby like this here. Number 1, that's in the upper left. What angle is also in the upper left? Number 5? So if you kind of look at that, maybe I'll try to scribble it out. If you look at that top kind of grid work of 4, and then if you look at the bottom grid work of 4, you know how they basically look the same. So if we have number 1 or angle 1 and 5 are in the same place. Angle 8 is corresponding with angle 4. Yep, because they're both kind of in the bottom right. Agreed? But that's probably, of my ones, that's probably the one that's the most kind of hokey. And bad things are happening. Okay, corresponding. So corresponding angles then, what did I write? So same side of transversal and the line it's crossing. And if you wanted to, you could put a thing in there. They have to be congruent, because that'll narrow it down really to like half of your options. If you know they're the same number of degrees. Congruent, at least, if you have parallel lines. Right. So example, we said number 1 then is corresponding with angle 5. So angle 1 is congruent to angle 5, or angles 1 and 5 are corresponding. And angle 4 and angle 8. Because 4 and 8 would be there, 1 and 5 would be there. So kind of same place. All right, can I keep going? Sure. All right, then vertical angles. For me, the way I remember those is I think the vertical, do you agree that kind of looks like an arrow? Yes. Especially if you put that in there. So for me, I think vertical angles, they kind of point to the other one. So if I were to go up here, so my first example is angle 1. If I turned angle 1 into an arrow, it points at angle 4. So 1 and 4 are going to be vertical angles. Let's see exactly what I kind of meant to write, but we could say angle 1 and angle 4. They're the same number of degrees, which we said they have names, but vertical angles are on opposite sides, or maybe opposite each other. Opposite each other when two lines intersect. And if you wanted to, you could, try to do like the arrow thing there, or for this you could say or corresponding. If you think that'll help you. If you don't, then I just made myself look bad. But hey, it's all good. So angle 1 and 4. And the other one, so this I just zoomed in right here on the thing up above so I could see it all. Angle 1 and 4, or angle 2 and
3.
Angle 3. So that's our page 1. How you doing? That's the bulk of the new stuff. We have just a little bit more to go here in the end. But any questions on those? So some of these are just memorizing. You know, that those who like study the stuff and memorize it, they do better on the quiz. The ones that are kind of like, it's good. You know, they're the ones that sometimes get it wrong. So, perpendicular. The symbol for perpendicular is a horizontal line with a vertical line hitting it in the middle. So perpendicular, something like that. And if you have lines that are perpendicular, they form how many degrees for an angle?
90 degrees.
Perfect. So lines that form a 90-degree angle. So if I wanted to look at this drawing over here and say, hey, look, they're perpendicular. You know, you could have the little like right angle thing here. Looks like my dot's a little high on that one. But you could say x, y. If I want to say this thing here for x, y, what do I put above my x and my y? Oh, just like the little segment thing, just the kind of the bar is perpendicular to the other one, which is PU. I was bored while typing up notes. X, Y, and PU. I should just move on. As you could point out that guys have an X and a Y chromosome, and guys stink. Okay. Sorry. Too much sugar. Okay. Perpendicular bisector. If it's perpendicular, we know it has to. It's perpendicular to a line segment. But if it's a bisector, we know it has to cut it in half. Perfect. So divides the official math thing. If you know cuts it in half, that's totally fine. But divides the segment into, I want to say equal, but in geometry we don't say equal, we say
Perpendicular.
Two
Congruent.
Nice, two congruent parts. So referring to this thing up above, you could say PU, with a little line thing above it, is the perpendicular bisector of XY with a bar over it. So the line PU is the perpendicular bisector of segment XY if which two things are congruent to each other? Maybe I'll give you one. XM, the segment XM right here. If this here is congruent to MY. Nice, this one right there. So MY. And you'll recall, hopefully, that the equals with the squiggly over it, or the equals with the tilde, that means congruent. That's it. A couple very final things. One, if you see notation like this, so say lowercase m, then an angle A. What they're talking about there is the m stands for the measure of angle A. So we'll say, we know the measure of angle A, it's 30 degrees. And I'm just going to pretend this is angle A. So this is 30 degrees. You'll see some homework in the questions then that ask you to figure out other angles, such as this one here. Well, if you look at this line here, you could say this angle and this angle are supplementary, that they add up to 180, because a straight line is just a straight angle. So if we're trying to figure out what this is right there, you could say, well, I know the whole thing, I know this part plus this part, all together has to add up to 180. So if I do the whole 180, then take off this 30, I know this right here has to be 150 degrees. And then from there, if you wanted to figure out the other angles, you could say, oh look, this here, these two are vertical angles with each other, so I know this has to be 150 degrees. Or you could go right back to your supplementary angles. Now if this is a straight line, this 30 plus this part here has to equal 180. So 180, take off the 30, then gives you this part right there. Or And you could do the same then for figuring out this angle here. So this together is 180, or that's 180, or just say, look, a vertical angle. So this has to be 30 degrees. So several of the questions on the homework are trying to figure out angles. Just kind of hack around with it a little bit. They're really kind of fun once you get the hang of it.